So you're supposed to solve using synthetic division. So first thing I'm going to do, I've got x minus 3 there, so I'm going to draw a little box and put a positive 3. Got to reverse the sign, so I have 2x to the 4th, and then negative 8x cubed, and then 0x squared. There's no x squared, so I put a 0 there, and then 12x, and then minus 14. And I draw a line here, and I bring down the 2, and then multiply, write the result, and add. And multiply, write the result, and add. And then multiply, write the result, and add. And then multiply, write the result, and add, and I get negative 32, which seems really big, so I don't know if that's right or not, but we'll find out. So my final answer, this used to be 2x to the 4th, now it's 2x to the 3rd, minus 2x squared, minus 6x, minus 6, with a remainder, it's going to be plus negative 32 over x minus 3. Do you feel like you're on Sesame Street right now?
Yeah, a little bit.
If we had a puppet, you know, it'd be kind of like that. Like, let me tell you how to do complete the square. Okay. And you're kind of like the helper on Sesame Street. Okay. So the first thing I want to do to complete the square, I'm going to move the 11 over. So I get a squared minus 12a, and then I leave a space, and then I have negative 11. Okay? And then you look at the b term, the thing next to your non-squared variable, and you do half b, which is 6, and then square b, which is 36, and then add b to both sides. I made this up too. Mr. Delt didn't, but somebody might think that he did sometime, or say he did, but really he didn't. Okay, now, I'm getting ahead of myself. I'm so excited about the fact that I made this up that I'm not telling you what I'm doing. Okay, here's what I'm doing. This is now a perfect square trinomial because of what I did right here. That forces it to be. When you have a perfect square trinomial, the shortcut to factoring it is you square root the outside terms.
A plus 6.
Well, but you bring down whatever sign is in the middle,
Oh, yeah,
so minus.
A-.
And you square the whole thing. Now, if you don't want to do it that way, you could still do it using the ACB method. You'd get a minus 6 times a minus 6.
Yeah.
Okay?
I'm never going to do that.
And then the ACB, or
Complete the square.
Oh, you know, I've only known one person in my entire life that was good at completing. He completed the square even when he didn't have to. He just, I don't know. Negative 11 plus 36 is 25.
Okay.
And now I have a square here, and this is a perfect square, so that makes it nice too. So I'm going to square root both sides.
Oh, you square root?
Square root it, yep. And so I get plus or minus on the right. Yep. And then on the left, the squared and the square root cancel. I just have a minus 6.
Do you add 6?
You will, but you might want to split it up in 2 because sometimes people make a boo-boo here. Like what they'll do is they'll add 6 to both sides and say, oh, the answer is plus or minus 11. And that's not what happens.
Oh.
You add 6 to this one, and yeah, you do get 11. But when you add 6 to a negative 5, you don't get negative 11, you get 1. So you got to be really careful at the last step that you don't just say, oh, I'm going to add 6, I get plus or minus 11. You got to think of it as 2 separate problems. There we go.
One's 11, but one other is 1.
Okay, so I'm going to use long division for this one. So let me draw a little line here. And I put 5x cubed in there, minus 10x squared, plus 19x minus 8, and I'm dividing by 5x minus 2. And then what I do is I look at the leading terms here, and I say, what would I need to multiply 5x by to make it 5x cubed? So that would be x squared. So I'm going to write an x squared right up here in the x squared column, yeah. And then I multiply it out, so I get 5x cubed, then times negative 2, so I get negative 2x squared. And then draw the line and change the sign. I made that up. Mr. Delp did not make that up. I made it up, just in case that ever comes up with anybody. Okay, and then the 5's cancel, and then I have negative 10 plus 2 is negative 8x squared, and I bring down the 19x, and what do I multiply 5 by to get negative 8? Well, let me figure that out. 5 times something gives me negative 8. And I can kind of treat this like an equation and solve it.
Oh.
See that? So that means the thing I was looking for was negative 8/5.
Oh.
And I also need an x because it was x squared. So negative 8/5 x. Another way to think of it is, this 5 here will cancel the 5 there because it's in the denominator, and this one's kind of on top. So this becomes a 1, and then you multiply by 8 to make it an 8.
Oh.
Okay, so negative 8/5 times 5, I get negative 8 x squared. And then negative 8/5 times 2, ooh, that's going to be, well, you multiply the 2 and the 8, you get positive 16 over 5, and then x. Okay? And then draw the line and change the signs. I made that up. Mr. Delp might try to steal that someday, but just trust me, I made it up. Okay, and then you cross those out. And then I use my calculator here because I can't do fractions very well. It's a shortcoming of, oh wow, I didn't know I could do that. Whoa, that is great. Ooh, that I never knew I could do that. That is like the biggest screen I've ever seen. Okay. Okay, so anyhow, I have 19 plus, or I could have done minus, I guess, and then hit the fraction button, and then negative 16 over 5, and I get 79 over 5. I hope that's right because it seems really ugly. So 79 over 5x. Ooh, yuck. Did I really give this problem to people? That can't be right. Okay, and then I bring down the negative 8. I must have really hated these people when I did that. Okay, now I have to multiply 5 by something to get 79 over 5. 79 over 5. I'm going to solve it again. I'm going to treat it like an equation, so I divide both sides by 5. In other words, I'm multiplying this by 1/5, or you can put it in the calculator, and you can do 79, so fraction 79 fifths, and then divided by 5, 79 25ths. Okay, so I have to put plus 79 25ths. So 79 25ths times 5 should give me 79 fifths. I don't have to calculate it because that's how I set it up.
It should be right.
Yeah, well, I mean, I hope it is. It may not be, but I wouldn't expect it to be different if I did everything right. And then 79 25ths times negative 2. Oh my goodness. People are going to freak out when they see this at home. So I multiply that by negative 2. And I get negative 158 over 25. I keep thinking I must have made a mistake somewhere. This seems like an outrageous number. So I take my negative 1. I'm not going to give you one like this in the test, by the way. I promise. But I take my negative 158 over 25, and I draw the line and change both the signs. So those cancel. And that gives me negative 8 plus this whole thing. Whoops, whoa, that's not the thing to do. So I'm going to go up here and hit enter, paste that down into the next line, and then I can just delete the negative that's out in front here.
Oh, okay.
I just hit
How do you paste?
delete. Whoa, no! Whoa, not like that. Okay, I scroll back up and hit enter. You scroll back up over what you want to work with, and you just hit enter, and it pastes it down for you.
Oh,
Okay, so let's see here. I can't read my buttons. Delete. Oh no, I cleared it.
It's tiny.
Enter. Yeah, it is. Okay. Delete. Oh! That's the table. That must be the table button.
I'm easily amused.
This is crazy. Okay, I gotta make this bigger. I cannot see these buttons. Oh yeah, I kept hitting the data button is what I was hitting. Delete is above it. Okay, delete. There we go. So now I have that, and then I forget what I'm doing with it. I guess I'm combining it with negative 8, so I'll put minus 8. And that's going to be my remainder, negative 42 over 25. At this point, I'm just going to put R, negative 42 over 25. Is that what I said? Okay. I think so, too. On the test, I'll make sure they come out better than that. I'm almost thinking I must have made a mistake somewhere because I just can't believe that it really came out that bad. But I don't know. I guess it's that bad.
That's okay.
Okay.
Alright.